Good morning everyone, my name is HENG and my metric number is 202453. Today I'm going to explain about and give a bit brief about the basic concept, the force system, equilibrium and also frictional analysis of static system. Without further ado, let us go to the first content, the basic concept. There are four basic quantities that are focused in static, that is length, time, mass, and force. While there are three idealizations in mechanics, which is particle, rigid body, and also concentrated force. What is particle? Particle actually has a characteristic of it has mass, but its size is insignificant, while rigid body does not deform when force applied. A concentrated force represents the effect of loading, which is assumed to act at a point on the body. Now, let's look at the Newton's law of motion. The first law stated that an object is in equilibrium when moving with constant velocity. The second law stated that an object experiences acceleration when subjected to net force, F equals to ma. While the third law stated that the mutual forces of action and reaction between two particles are equal, opposite, and collinear. For example, a 900 Newton person standing on ground, the ground at the same time will also apply 900 Newton normal forces to that person. Unit of measurement. We actually using SI unit and US customary in static. For example, SI unit we have kilogram, meter, and for US customary we have pound and feet. Prefixes. Prefixes are symbols that are used to simplify the digits that are very big or too small. Here, table 1-3 are the example of prefix. Now let us discuss about the dimensional homogeneity. The term of any equation used to describe the physical process must be dimensionally homogeneous, that is, the term must be expressed in the same unit. For the example, the equation of motion here shows us that each term has the meter as the unit. Okay, let us go to the content 2, force system. There are two physical quantities, that is scalar and vector. Scalar is a physical quantity that consists only magnitude, for example, mass and temperature. While vector is a physical quantity that consists both magnitude and direction, for example, velocity, force, and momentum. There are two ways to perform vector addition. The figure here shows us how to perform the two methods. The first one, parallelogram law of addition, and the second one is the triangle rules. Vector subtraction. Vector subtraction and vector addition is the example of vector operation. Vector subtraction is similar with the vector addition by just changing the direction of vector. Now, I will show you how to find the resultant force. To find the resultant force, we will stick to these two procedures. The first one, we draw a half portion of the parallelogram to illustrate the triangular head-to-tail addition of the component. From this triangle, the magnitude of the resultant force can be determined using the law of cosine, and its direction is determined from the law of sine. The magnitudes of two forces components are determined from the law of sine. The table here showing us the formula of law of cosine and law of sine. Addition of a system of a 2D forces system. When forces is resolved into two components, x and y axis, the components are then called rectangular components. There are two ways we can represent the resolved component, which is scalar notation, and the second one is Cartesian vector notation. Scalar notation will show us the magnitude and also the angle started from x-axis, while the Cartesian vector notation will show us the resolved component at x and y axis, which is more convenient for us to calculation. Here are some steps for us to calculate the resultant force in scalar notation. The first one, resolve all the coplanar forces into Fx and Fy component using the formula below. Then sum all the Fx and Fy component using this formula. After that, we can use the Pythagoras theorem to calculate the magnitude of the resultant force. And finally, for the direction of resultant force, we can straightly use the trigonometry identities to find it. While the Cartesian vector notation form, we just simply add up all the coplanar forces according to the I and j component, as shown in the step here. Then the Cartesian vector and scalar notation are interconvertible using the Pythagoras theorem and the trigonometry. Let's look at the example. To determine the magnitude and the direction of resultant force, first we need to draw the free body diagram and include all the information given into the free body diagram. Then resolve all the forces into x and y component. After resolve it, sum all the x and y component respectively as shown in the step here. Then after we get the frx and fry, we can put it into the Pythagoras theorem to find the magnitude of resultant force. For the direction of the resultant force from x-axis, we can use the trigonometry method to find it. Now for the solution to the Cartesian vector notation form, we can just add up the x and y component respect to I and j accordingly as the solution shown here. Now let us look at the Cartesian vector in 3D system. When we encounter question like this situation 1, forces are given in Cartesian vector notation, but resultant forces are requested. Then the calculation is similar with 2D force system. Apply this formula here and calculate the magnitude of resultant force using the Pythagoras theorem. While in situation 2, resolve a force into x, y, and z component when coordinate direction angles alpha, beta, and gamma are given. We can use the direction of cosine to find the component and also use the important relation to find the rest of the angle. For the situation 3, when we are requested to resolve the forces into x, y, and z component with the information of transverse and azimuth angle given based on the diagram, first we need to resolve the a to become az by cos the phi angle, and then resolve the a to a prime by sin the phi angle. After getting the phi a prime, we can get the ax by cos the a prime become ax, and the ay we can find it by get the a prime sin the theta angle to get the ay. Here are some simplified formula that are summarized for you guys. Now we are going to discuss about the content tree, the equilibrium. A particle is said to be in equilibrium if it remains at rest if originally at rest. It has constant velocity if originally in motion. The equation of equilibrium are fx equals to 0 and fy equals to 0, which means that all of the components that result from the forces and the summation of them is equals to 0 if the object is in equilibrium. While the equation of equilibrium for rigid body is also same as the equation of equilibrium for normal object, but the most important one is the this is the summation of the moment is also equals to 0. What is the moment? Moment is actually torque, which is the tendency to rotate. The moment has the formula of force multiplied by the distance from the pivot, and also the force applied and the distance from the pivot must be perpendicular. If the moment from clockwise, the moment have a value of negative, while the anti-clockwise moment have a positive value. Let us look at the first example. Determine the tension in cable AB and BC necessary to support the 60 kg cylinder in the figure. Okay, let us assume that this cable is TC and this cable have a tension of TA. Since we don't know TA and TC, but we are given the weight of the cylinder. First, we need to draw the free body diagram and put all the information inside. And since the system is in equilibrium, so the equation of equilibrium will be used. The summation of x and y is equal to 0, so we have to resolve TC into component x and minus with the x component x of TA. Since both of them are in opposite direction, so one of the term must be in negative. For y component, we can add up the sign of TA and TC and minus with the weight of cylinder to yield equation 1 and equation 2. By solving the simultaneous equation, we can simply get the TC equals to 476 Newton and TA equals to 420 Newtons. Okay guys, let's have a look on example 2. Determine the tension in each cord used to support the 100 kg crate. The weight of the crate is 981 Newton. First, we need to assume that the cord AC and AB is 1 meter, which is the unit vector of the cord. We know that the force vector is equals to the magnitude multiplied with the unit vector. Then to find the resultant force B, we just need to multiply the magnitude with the unit vector, as shown here. The first equation, and for resultant force C, we need to convert the coordinate direction angle into Cartesian form before we can multiply with its magnitude. Because here the gamma, alpha and beta angle are given, so we need to convert in Cartesian form before we can start to multiply with its magnitude. And all the magnitude here are written in italic form. While the force vector D, we need to find the coordinate at point D first, which is the -1, 2, 2 for the Z, and we can convert it into Cartesian form and divide it by its magnitude to get unit vector AD. Multiply with unknown FD, which is the desired magnitude, to get the equation of force vector in Cartesian form. While the magnitude of weight is 981 Newton in negative k direction, so we have to add the negative sign into the equation. Since the system is already in equilibrium, so the equation of equilibrium will be used. The net force is equal to 0. Also, the summation of all the forces vector will be also equals to 0. So respect with I, J and K component, this allow us to yield the equation 1, 2 and 3. After getting the 3 equation, we can solve for FC, FB and FD by solving the simultaneous equation. So the FC will equals to 830 Newton, while the FD will equals to 862 Newton, while the FB will equals to 694 Newtons. Okay, let us discuss about the example 3. The box wrench in the figure is used to tighten the bolt at A. If the wrench does not turn when the load is applied to the handle, then determine the torque or moment applied to the bolt and the force of the wrench on the bolt. Okay, first, as we can see, the system is in equilibrium, and therefore the equation of equilibrium will be applied. And first, to solve this question, we have to draw a free body diagram and extract the important information inside and put it in the diagram. The first one, we have to resolve the component into x-axis, into x component and y component, and the summation of the x component will equals to 0, and same with the y component will also be 0. And this allows us to yield the equation here, and the equation this one, and ax will be calculated as 5 Newton and ay is 74 Newton. And the last one is the most important one. For equilibrium in rigid body, the net moment will also equals to 0, because according to the Newton's third law, there is a opposite moment that support this wrench and preventing this wrench from turning. The moment applied by the hand is clockwise, therefore the value is negative, while the opposite moment applied by the bolt is anti-clockwise, and therefore the value is positive. The formula of moment is the force applied multiplied with the distance from the pivot at here, which is the distance from the bolt. Also make sure that the force applied is in perpendicular with the distance from the bolt. To start the calculation, we put inside the MA and multiply and minus the moment that provided by hand, which is 52 multiplied with 12 over 13 and 0.3 meter by the first hand from the pivot, and minus 30 sine 60 degree and multiply with 0.7 meter from the second hand. So from this equation we can solve for MA, which is equals to 32.6 Newton meter. After that, we need to find the force of the wrench on the bolt, which is the FA. Since we already have the AX and AY, we put both of the value inside the Pythagoras theorem to get the resultant force of A, which is 74.1 Newton. Well, for the last content, which is the frictional analysis under static condition. What is dry friction? Dry friction is a frictional force that exists between two rough surfaces to contact. These forces act on a body so as to oppose its motion. There are two frictional forces, which are static and also kinetic frictional forces. Static frictional forces is the friction that exists between the object and the surface when the object is at rest, while the kinetic frictional forces is the friction between the surface and the object which is moving. The formula given here is to calculate the static frictional force and also kinetic frictional force. The mu s in the first equation is the static frictional coefficient, while the mu k in the second equation is the kinetic frictional coefficient. Wedges are inclined planes that used to increase the application of the force. When we encounter the question or problem that is related to wedges, we can use the formula here, which is the summation of x component is equals to 0, and also summation of y component is equals to 0. Screws. Square-threaded screws are used to move heavy loads that represent an inclined plane wrapped around a cylinder. Moment depends on the coefficient of friction and the screw lead angle. If the coefficient of friction between surfaces is large enough, the screw can support the load without tending to turn. Here we have two formula for us to calculate the question that is related to screw. The first one is outward impending screw motion. The first formula, or the second one is about the second and third one is about the downward screw motion. For the second one, the phi angle, if the phi angle is larger than the theta angle, we will use the second one, while the third one, with the theta angle is bigger than the phi angle, which is the condition is downward impending screw motion, we will use the third equation to calculate. Flat belt. The force needed to move a flat belt over a rough curved surface depends only on the angle of belt contact and the coefficients of friction. To solve the question related to flat belt, we will use the formula given and also take an eye on the belt angle is the beta and is always in radian. Also, noted that T2 is always larger than T1. The collar bearing and disc. The normal force is determined from the force equilibrium along the shaft. Moment needed to turn the shaft at a constant rate is determined from the moment equilibrium about shaft axis. The formula here given is for us to calculate a question related to collar bearing and disc. Journal bearing. When a moment is applied, the shaft tends to roll up the side of bearing until slipping occurs. When we encounter a question that is related to journal bearing, this equation can be used. The capital M represents the moment, and the capital R represents the bearing reactive forces, and the small letter r is the radius, and the phi k is the angle of kinetic friction. Rolling resistance. The resistance of a wheel to rolling over a surface is caused by localized deformation of two materials in contact. The formula here given for us to solve the problem related to rolling resistance. P is the driving forces, W is the weight of the roller, and A is the coefficient of rolling resistance, and R is the radius of the roller. Here is the example that is related to frictional analysis. It is observed that when the bed of the dump truck is raised to an angle of 25 degrees, the vending machine will begin to slide off the bed. Determine the static coefficients of friction between the vending machine and also the surface of the truck bed. First, to solve this question, we need to draw a free body diagram as usual, and also put all the information inside. And since the system is equilibrium, therefore the x component, the net force in the x component will also equals to 0, and also the net force of y component will also equals to 0. This will give us the equation 1 and equation 2. Since we know that the object is at the rest, so we will apply the equations of static frictional force equation, which is Fs equals to mu s multiplied with n, which is the normal of the normal force. So by substituting the first equation and the second equation into the static frictional force equation, this will give us the equation of this, and we can simply calculate the static coefficient of friction, which is equals to 0.466. That's all from me. Thank you.